The next topic that we are going to discuss about is Amazon Relational Database Service or Amazon RDS. So first of all, we would be talking about all the features of managed service, that is managed RDS service that we have. We'll be talking about different RDS engines because when we talk about relational databases, in relational database as well, we have multiple flavors. Like we have MySQL, we have Microsoft SQL Server, we have Oracle. All of these are relational database services. So what all engines are being supported on RDS? We'll be talking about multi-AZ deployments and the failovers. What is this concept and how it will be beneficial for us? We'll be talking about read replicas, the resource-based policy which can be applied to RDS, the data encryption. So the data would be encrypted at rest when we are using RDS if we want. We'll be talking about Aurora. We'll be talking more about Aurora into the DB clusters. We'll be understanding how Aurora actually works. And we would be talking about the serverless option of Aurora which is being available and what are the advantages of using that. So let's get started with the first topic, that is RDS features. So the first feature that is highlighted over here is it supports multiple database engines. So if you want to have MySQL database, if you want to have MariaDB, Postgres, Oracle, SQL Server, all of these database engines are being supported by RDS. You can have automatic backups. You can decide, okay, that how do you want your backups to be on RDS. If you want to create the daily backups, you can do so. If you want to create the snapshots, you can do so. So these daily backups can be used to restore the database in case of data loss or corruption. It provides us with high availability using multi-AZ deployments. So we will be discussing this multi-AZ deployment very soon. So these are the advantages of using the managed service, because if you are not using the managed service, high availability, scalability, all of that comes under our responsibility. So we have to make sure that our EC2 instances which are hosting our database, okay, should be running into multiple AZs, right? And we have to maintain the scalability as well, that if the load on database is being increasing, then we have to increase our instances as well in the unmanaged environment I'm talking about. But here when you use the managed environment, the scalability is taken care by RDS itself. So it can scale up and scale down as required. The other features include security. So we can have number of security features included over here if you want to isolate it using Amazon VPC, if you want to use SSL encryption, if you want to use IAM authentication, all of that can be done with RDS. We can also apply the policies, that is resource-based policy on RDS for controlling the access. Apart from that, it provides us with monitoring and metrics. So RDS provides monitoring and metrics capabilities through Amazon CloudWatch, which allows users to monitor database performance, set alarms for critical events. So if you think that your database is having high amount of read requests and you want to get notified for that, the read requests that you would have provisioned are being exhausted up to 90%. Okay, they are being used 90% and now still you are getting the requests and there are chances of failures. So if you want to monitor that, then you can also do it by the capabilities of CloudWatch. What is CloudWatch? We are soon going to discuss it. Lastly, because it is a managed service, it is easy to use. You can launch your database within few clicks without needing to worry about the underlying infrastructure. And everything would be managed by AWS. So these are all the features which makes RDS a good choice for running your relational database on AWS. The next topic is RDS engines. So if we talk about different RDS engines over here, then we have the option of SQL Server, Oracle, MariaDB, MySQL, Postgres, and Aurora. Before we go into the depths of this, let us talk about something called as DB instance. Okay, that is database instance. So DB instance is nothing but it's an isolated database environment in AWS cloud. This is the basic building block of RDS. So your DB instance can contain one or more user created databases. You can access your DB instance by using the same tools and application that you can use with standalone database instances. You can create and modify a database instance by using the AWS CLI, Amazon RDS API, or the management console. Now, we have talked about these different engines that we have, right? So database engine is nothing but it is specific relational database software that will be running on your DB instance. So when you create your DB instance, you have to decide that which engine do you want to run on that particular DB instance, right? So again, obviously, whenever you are creating your database instance, you would require some storage for it, right? So EBS provides durable and block level storage that you can attach to your running instances. And these again have different kind of options for attaching those EBS volumes. Okay, then the volumes do have different kind of options. You can go with SSD, you can go with provisioned IOPS, or you can go with magnetic. So these are the different storage options that we can have. They differ in performance, characteristics, and obviously price. So according to the need of your database, you can select any one of this. Right. Now we will be trying to discuss all of these database engines in, depth. So let us first try to understand about Microsoft SQL Server. So when you have the SQL Server, it supports multiple versions and edition of Microsoft SQL Server. The most recent supported versions basically are SQL Server 2019. Okay. So there are some limitations over here as well. So I've told that we create the DB instances, right? So by default, you can have 40 DB instances. So RDS DB instances, Aurora DB instances, Neptune instances, and Document DB instances apply to this particular quota. So if you see about the limitations, then you can create 10 DB instances for each SQL Server edition under the license included model. Okay, so that's one of the quota which is being given to us by AWS. The next topic that we are going to discuss is the Oracle flavor on RDS. So it runs on the following, versions and editions. Like you can have Oracle Database 21C, you can have Oracle Database 19C. So you basically can run your Oracle supported databases on this particular database instance, right? And you can have as well multi-AZ deployments for higher availability and failover solutions. The quota for Oracle DB that we have is you can have again 10 database instances for Oracle under license included model. Then after we have MariaDB, right? So in MariaDB as well, it is fully managed service. It can run on the versions of MariaDB 10.6, 10.5, 10.4, 10.3. So 10.3 is soon going to expire in October 2023. And the quota for MariaDB. Let us see the quota now. Okay, so the quota for MariaDB is 40 DB instances for MariaDB. It also applies the same quota for MySQL and Postgres. Okay, you can have 40 DB instances for MySQL and Postgres as well. So when we talk about now MySQL version on RDS, then it supports the version MySQL 8.0 and 5.7. So these are the two versions which are being supported of MySQL, right? Other minor version support is also there. So when we create the DB instance for MySQL, we can resize our DB instance, we can authorize connection to your instance, we can create and restore from backup, we can create multi-AZ secondaries, we can create read replicas, right? So all of these things can be done. Again, 40 DB instances of MySQL can be created over here. The next flavor that we are going to talk about is Postgres, right? So when we talk about Postgres, then it supports several versions of Postgres. And if we talk about the quota, okay, then the quota would be 40 instances. Okay. So we have the versions like, we have Postgres version 14, we have Postgres version 10. So we have these versions supported on AWS Postgres. Other older versions are being, deprecated and they no longer are being supported on AWS. Then lastly, we have Aurora. So I'm not going to discuss Aurora here in depth because we do have different slides for that dedicated to Aurora. But Aurora is a high performance engine that we have, and it only supports MySQL and Postgres. It is very fast and high performant. How it is high performance, how it will work, we'll be discussing that later in our course. So let us now discuss about multi-AZ deployment. So as the name suggests, okay, multi-AZ, that is multiple availability zone deployment. So when we talk about multi-AZ deployment, it would be providing us with high availability. It is a common practice for high availability as well as disaster recovery in cloud computing platforms. So if we talk about AWS, then availability zone we know is a separate physical location with its own power, cooling, network infrastructure, which is isolated from other AZs to prevent failures from affecting other zones. So deploying resources in multiple AZs ensure that if one of the AZ experience a service interruption or outage, the resources can fail over to another AZ without disruption to your application, right? So if we see over here, when we have the multi-AZ deployment for RDS, AWS will automatically provision the standby database instance. So initially, we have two EC2 instances. These are nothing but application servers. Okay, these both instances are application servers, and application servers generally work with the backend databases. So both of these EC2s would be sending their traffic to the primary database instance, which would be there into one particular availability zone. But we also have one standby database instance. The primary DB instance and the standby would be in sync with each other. So synchronously, the data would be copied from primary DB to the standby DB instance. Okay, so replication is done in near real time, ensuring that both the instances of the database have same data all the time. Now, if by any chance the primary database instance is failing into first availability zone, then what will happen? Our secondary database instance or the standby database instance that we had would be automatically promoted to primary. Okay, this is a automatic process. There's no requirement of manual intervention, so it will be automatically promoted to primary. And a new standby database instance would be created into availability zone 1. Again, the sync of the data would start automatically here. So this is multi-AZ failover. So in case of failovers, we can automatically promote our standby instance to the primary without disrupting our customers or without disrupting our application. And also along with that, we would be creating another standby database instance. So here the read traffics, even see if I have two database instances, okay, it doesn't mean that if any read traffics are coming, that can be, it would be easier if I have my availability zone 2. I have one standby database instance in availability zone 2, and this application server wants to read the data. So it doesn't mean that it can read from the standby database instance. So read only traffic is being not supported by standby database instance. If you want to have some kind of solution for your read traffics, okay, that understand the read traffic that is coming to your database is in high amount. Okay, for let's say report creation, I want to read my database. So for that, if we just redirect all our traffic to our primary database instance, then our primary database instance will get slower down. And we do not want that. So what would be the solution for that? So the solution would be read replicas. So read replica would be allowing us to scale horizontally to handle just the read traffic. Okay, this would be just working with read traffic. If you want to read from this particular database, only read queries would be allowed. And here in the primary, both read and write would be allowed. And this would be copying the data asynchronously, not synchronously. So if we want to offload reporting to reduce the load on primary database, then we can do so over here. We can replicate data across multiple AWS regions for improved availability and disaster recovery. So that's where read replicas comes into the picture. So the next topic that we are going to discuss over here is about resource policy. So when we talk about the resource policy, we know that we can have the resource based policies, right? There are two types of policy: identity based and resource based policy. Because RDS is our resource. So we would be applying the resource based policy on RDS for managing the access control. So again, it would be one JSON document because all the IAM policies are the JSON document, which defines the permissions that who can or who has the authorization to access this particular RDS. So you can use this resource-based policy for controlling the access on database instances, on snapshots or parameter groups. It allows you to grant the access to specific users or roles while denying the access to others. So this helps us apply the principle of least privilege. So resources would be only accessed by those, or RDS would be only accessed by those who require it. For example, if EC2 instance require to access RDS, then what we have to do? We have to attach a role with EC2 instance. Okay, in the form of instance profile. So this is what needs to be done. So you can specify the elements such as principles, actions, condition, and resource on resource-based policy. Let's see one example. So here we have the version of this policy, we have the statement, we have effect, which is allow. So we are allowing something over here. It can be either allow or deny. To whom we are allowing this? We are allowing this to this particular root user only. In this particular account, whoever is the root user, we are allowing him or her to do something. What are the actions that we are allowing? All the actions under RDS. If you want to have specific actions over here, right, just to read the database, just to have the right permissions, or just access to the snapshots, then also you can have different actions over here. And what is the resource? The resource is RDS, which is there into US East 1, and with the account number this, and the name of DB is test DB, right? And what's the condition? The condition says that the source IP address should be this or this. It should be belonging to either of this network. If that is the case, then the root user is being allowed to access this particular test DB, which is there in US East 1. I'm reiterating this again for better understanding. We are allowing the access to RDS where root user can perform all the actions to the database called as testdb, which is being deployed in US East 1 region, and that too if the traffic is being generated from this particular networks. So this is how you can create your resource based policies, and you can attach this with RDS. The next topic is data encryption. So when we talk about data encryption, there are two types of encryption possible. So either we can have RDS managed encryption or we can have KMS managed encryption. So we have talked about encryption into S3 as well. So we have SSE S3, right? So what will happen in RDS managed encryption? It uses the KMS to encrypt the data at rest. You can enable this option when you create a new RDS instance or modify an existing one. So RDS automatically manages the keys which are being used for encryption and decryption, and you can choose to use either default RDS managed keys, or you can also provide your customer master keys. Then we have KMS managed encryption. So you can create and manage your own keys on key management service of AWS using the customer master keys. So that keys would be then used to encrypt and decrypt your data. So again, you can enable this option while creating the RDS instance, or you can modify it later as well. And you have to specify that which key you want to use for data encryption. The other types of encryption over here are TDE, that is transparent data encryption. It is a feature that encrypts the data at the file level within Oracle or SQL Server database. So it is specific to the database engines that we are selecting. So TDE would be encrypting the entire database, including the system tables, temporary files, or backups, and it is managed by database engine itself. So you don't have to do anything extra for that. You simply need to do few clicks and TDE would be enabled. When we are using the storage engines, so you can have encrypted storage engines as well. So we have Aurora, which supports encryption at rest natively. So with these engines, the data would be automatically encrypted. You won't even get the option to turn on the encryption. It would be automatically encrypted when the data is written to disk and decrypted when it is being read. So this is called as encryption at rest natively. Now we are going to discuss about Aurora. Okay. So Aurora is one database which is created for MySQL and Postgres compatible. It is just two engine support. Okay, MySQL support and Postgres engine support is there, which is built for AWS cloud. It is one of the flavors of RDS. So what are the features that are there for Aurora? The high performance, scalability, security, fully managed, and we do have the serverless option over here. So why would we are choosing Aurora? It is because it is designed to deliver high performance, scalability, and availability while reducing the cost and complexity of traditional databases. It is 5 times faster than MySQL and up to 3 times faster than Postgres. So, what I mean by faster, it means that it can deliver up to 5 times the throughput of MySQL and 3 times the throughput of PostgreSQL without requiring changes to most of your application. Right. So, that's why basically the Aurora is being supported and it is being widely used. If we talk about the features, then when I talk about performance, we have already known that the throughput that is being given to that is being provided to us by Aurora is very high. So it uses the distributed architecture that is designed for high performance and low latency. So we'll be discussing about the architecture into the next slide. Then it has scalability. So it is designed to scale out by adding additional read replicas which can be created in minutes. And it can also scale up to support large workloads with more powerful compute and storage resources. Next, we have the security. Again, we can encrypt the data at rest. Here, the native encryption is being supported. We can attach the policies over here for authorizing the users. It is fully managed, so I don't have any operational overheads on me. And it is having the serverless option, which makes it cost effective. Right? So it offers pay as you go model. So whatever we are using, we are just paying for it. We are not paying for anything extra than that. So this is about the DB clusters. So Aurora DB cluster consists of one or more database instances and a cluster volume. So you can see this is database instance and this is a cluster volume. Okay. So cluster volume is a virtual database storage volume that can span across multiple availability zones, with each availability zone having a copy of DB cluster data. So we have two types of database instances. Now what we know what is cluster volume. Okay, cluster volume is virtual database storage volume. So this basically is storage volume. So why Aurora is fast? It is because that we have just bifurcated the instance and the storage. Okay, that's why it is fast. Right? So if we see over here, we can have two type of database instances. So database instance, primary database instance, which will support our read as well as write operations and will perform all of the data modification to the underlying cluster volume. So each Aurora DB cluster would be having one primary DB instance, that is compulsory. Then we have Aurora replicas. So Aurora replica would be connecting to the same storage volume as the primary DB instance. So each Aurora DB cluster can have up to 15 Aurora replicas in addition of primary database instance. It is used for maintaining high availability by locating Aurora replicas in separate availability zone. Aurora automatically failovers to Aurora replica in case of primary DB instance becoming unavailable. Also, you can offload read workloads from the primary database instance. So if you are having any read queries into AZ2, then you can use this Aurora replica for the same. So we know that there is a separation of compute capacity and the storage. And because of this, Aurora becomes very fast. The next topic is Aurora serverless. So when we talk about Aurora serverless, we know that serverless means we are not worried about the underlying infrastructure, right? And we do not have to scale up. We do not have to tell that how much of capacity I do want to provision. Okay, all of that is not our headache. It provides us with on-demand auto-scaling configurations. So, what are the features of Aurora serverless? So it starts and shuts down automatically. If you are getting the requests, then it will be started. If you are not getting the request, it will shut down automatically to reduce the cost. We are only being charged till the time the server instance or say the database instance is in start state. So this is following truly pay per you use model. So you will be only paying for the time that you are using your database. You're not provisioning anything. You're not saying that I want this many read requests or I want these many write requests to be accepted by my database. You will not be provisioning that. It will scale up and down according to the demand. Also, while it is scaling, there would be no application impact. So if it is scaling up or scaling down, your application won't be impacted by that. So this is all about Aurora serverless. So till this point of time, we have discussed about databases. We have discussed about the different types of databases, that is, basically categorized under relational and non-relational database. Then we have talked about different AWS services which provides us with database services. We have talked about managed and unmanaged database service. What is the difference between two and what can be the use cases for the same? We have talked about RDS, its features like multi-AZ deployments, multi-AZ failovers, read replicas, right? Then the database engines that RDS supports. At the end, we also discussed about Aurora and Aurora, how does it work, right? Why it is fast. So the working of Aurora was also being discussed. And lastly, we have discussed about Aurora serverless. So these are all the topics that we have discussed so far. The next topic that we are going to discuss is DynamoDB, but before we go to that topic, we'll be seeing a demonstration for this one and we'll be understanding that how RDS actually works. Okay everyone, so I am on my on my AWS portal and we are going to create one RDS database over here. So what are we going to do? I'll just go to RDS over here. It is already marked as favorite. If you don't see it over here, you can simply search it from the global search bar and you can go to the RDS dashboard. Okay. So once we are into the RDS dashboard, we'll try to create one MySQL database and we'll see how it goes. So we are on the database dashboard now. You can see DB instance. We can create total 40 of DB instances that we have already discussed into our quotas, right? So no instance is being used over here right now. We are being allocated with 100 TB of storage, right? And apart from that, we have the DB cluster, we have DB instance, all of those are zero. We do not have any snapshot. Snapshot are basically a way of creating the backup for our database, right? So we do not have anything as of now. So let's create one database from here. You can also restore it from S3 if you have any snapshots already created. But I do not have, so I'll just go and create a database. So you want to go with the standard create where you can set all your configuration details, or do you want to go with the easy create where you can, just create the database very easily with the best practice configurations. So let's go with the standard create just to understand all the configuration details. So what is the engine type that you want to select? So, we have Aurora, MariaDB, PostgreSQL, Oracle, MySQL, and SQL Server. These are all the different types of engines that we have. So I'll just go with MySQL over here, right? It can support the database size up to 64 TB, and it also supports general purpose, memory optimized, and burstable performance instance classes, right? We can have 15 RAID replicas per instance within a single region or 5 RAID replicas across the regions. Okay, so now we have selected the MySQL community over here. Community edition is what we will be getting, right? Do you want multi-AZ deployment? If so, you can just enable this. If you want the version that support the optimized writes, then also you can support this over here. But I don't want any of this as of now, so I'll just create it as it is. Now, which is the MySQL engine that you want? So multiple MySQL engines are being, supported over here. Like 5 and 8 are the major versions. Into that, we have different minor versions supported. So I'll just keep it with the latest 8.0.32. Right, that is what I'm selecting. Next, the templates. Do you want to create this for your production workload, for your development test, or for your free tier? So as of now, I'll be going with the free tier account, right? So when you go with free tier, you do not get the option of multi-AZ deployments. Okay. So I do not want multi-AZ deployment as well right now. So what would be the name of instance identifier? So DB instance is something which is the basic building block on RDS, right? So once it is created, you can create databases inside of it. So database one, let's just keep this default name. Okay, I just want to call it as database one. And this is the username admin. And if you want, you can have the auto-generated password, and you can also manage the credentials into a service called a secrets manager, which generally stores your secrets. Okay, and it also allows you to regenerate the password, rotate your passwords automatically or according to the life cycle that you have created. But as of now, I do not want to use the secret. So I have put master password and I have confirmed my password as well. So do you want the optimized write? This is something new. Okay, if you want the extra information about it, you can always select this info option over here. So optimized write feature skips the MySQL double write buffer while still ensuring data protection. Okay, so this will actually have the asset properties as well, and you can turn this up. You can achieve 2 times faster write throughput with this being enabled. But as of now, I do not want it because we are using the free tier. Okay, that's why we do have only burstable class over here. We do not have memory optimize and the standard class for the database instance classes, right? So I'll just go with the burstable class, that is dbt3 micro with 2 vcpus and 1 GB of RAM with network speed of this much. So I'm okay with this one. Okay, apart from that, what is the storage that is being required? So DB instance class would be giving us the compute, and the database requires both, right? The compute for running our queries and storage for storing our data. So for storage, I'll go with general purpose SSD, that is GP2. You can go with GP3, provisioned IOPS, or magnetic. These are the 3 different storage options that we can have. So I'll just go with GP2 over here. Baseline performance would be given and it would be determined by your volume size. So I'm okay with 20 GB of allocation as of now. I can also reduce this, right? But the minimum value is 20 GB, so I cannot go further down. For my workload, obviously, it won't be even going 20 GBs. Do you want storage or auto scaling, that if the storage is getting filled, if those 20 GBs are getting full, then do you want to exceed your particular storage? So if yes, you can enable this and it can go maximum threshold for 1000 GB. So I'll just keep this on as now, right? Compute resource. So choose whether you want to set up a connection to compute resource for this database or not. Okay, so if you select that, your EC2 will be able to connect to this database, but I do not want it as of now. Choose the VPC in which this DB instance would be going. So I'll be just going with the default VPC as of now. Okay, once database is created, you cannot shift to the VPC. So default VPC is fine for me. Apart from that, do you want this particular database to be publicly accessible? Generally, we keep this as no. Okay, only EC2 instances and other resources inside the VPC would be able to connect to your database. But if you want any other instance or any other resource outside of the VPC to connect to this particular database, you can specify this over yes. What is the security group that you want to apply to this particular database? So you can choose the existing one or you can create the new one as well. So let's say that I'll go with the private security group over here that should be applied. Into which availability zone do you want to have this database? I'll just keep it no preference. I'll let AWS choose that for me. Do you want the RDS proxy to be over here? So I do not want to create RDS proxy as well. I do not want any certificate authority. Okay. How do you want to get inside of your database? How do you want to get authenticated to your database? So you can use the password authentication that will be using the password, the master password and the username that we have used. Or you can use password and IAM, or you can use password and Kerberos authentication, right? So right now I'll just go with the password and the username. So username is admin and the password is something which I remember. So after all of this is done, if you want to enable the monitoring, you can enable it over here. So it can be going to your CloudWatch. We have already discussed about this monitoring feature, right? That it is one of the feature of RDS that it enables monitoring and metrics collection. So this can also be done. Now, apart from that, we have additional configuration. You can give the initial database name. So let's say I'll call this as sample DB and the parameter group is this one. So what is parameter group? So here again, you can select the information over here and whatever parameter group you select, okay, the configuration settings would be applied of that particular parameter group to your particular database. So do you want to enable the automated backup? If so, what would be the retention period? What is the backup window? That at what time do you want the backup to be taken? So you can go with no preference or you can go with selecting one window. If you go with no preference, AWS, generally whenever the backups are being taken, it would be taking it in that daily time range. But if you want to choose a window and give a start time and a duration, you can do it so. So I'll just keep it no preference as of now. And apart from that, do you want the replication of this backup into another region just for your disaster recovery? Okay, if your entire region is going down, then obviously your backup will also go down along with your database. So if you want some extra layer of protection, then you can replicate your backup into another AWS region. Then you have encryption. So do you want to enable the encryption or not? So I do not want to enable encryption as of now. Do you want to publish this log to CloudWatch? Error log, audit log, general log, slow query log. If so, you can just, check these, but I do not want that as well. Minor update version or, if there are minor version upgrades, then it will automatically take place into the scheduled window. So if you want this, you can enable this. Again, maintenance window you have to select. If you want to select a window, you can select it or else you can just give it no preference. Then there is deletion protection. So if this is enabled, then it will allow you or it will ensure that your database is not being deleted accidentally. Okay, so if this option is being enabled, you cannot delete your database, right? So once it is done, you can just click on create database, and this will allow you to create your RDS database. So these are the suggested add-ons. You can add your Elastic Cache or RDS proxy for it. But as of now, I do not want anything to be added on it, so I'll just close it. Okay. So it is still creating the database. As you can see here, it is showing creating. Okay, so once it is in the active state, we'll come back to this. Okay, so we have got an error. I'll just check on this, that why the incompatible network error is what we are getting. Okay, so generally we get this incompatible network error because the VPC and subnet settings that we specified are not in the same availability zone as the database instance preferred availability zone. Or it can be the case that we do not have required network configuration such as internet gateway or NAT gateway, or the required security groups or network ACLs are not being configured. Or the last thing is the settings that we have specified, the VPC and the subnet settings that do not meet the requirement for the database engine. So what I'll do is I'll just try to create another database instance. I'll just try to delete this as of now. Okay, because we have the deletion protection on, right? That's why it is not getting deleted. Just 1 minute. So this is how the deletion protection will help us. Do you see that? That I was not able to delete it because the deletion protection was on. I'll just disable this. I'll continue and I'll say apply immediately. And we'll be modifying our DB instance. It is being modified. Now what I'll do is I'll try to delete this. So now it is being deleted. And even when you delete it, you get another option to create your final snapshot, or you get the option to retain the automatic backups as well. So I do not want that, okay? And because of that, it is giving me warning that if you do not take backups or snapshot, then your data would be deleted. But because we do not have any data, I'll just delete this particular DB instance that I created. So now that is getting deleted, okay, what we'll do is we'll just try to create another database instance over here, but this time I'll just go with the easy create. That would be, creating the instance quickly. So let's go to easy create. I again want to go with MySQL database, and into MySQL I want the free tier. We'll call it database 2. Admin is the username. Password I'll put it over here. So I have put the password, I have confirmed it as well, and these are the default settings for our database. Okay, so once it is done, I'll try to create the database and let us see what happens now. The first database is getting deleted, the first instance, and the database 2 is getting created over here. Let's just try to refresh this and we'll wait till the time this is being getting created. Okay, now you can see that our database is available right over here. One action that is being suggested is that our DB instance isn't a multi-AZ DB instance, so you can make it multi-AZ, right? So that is the action being suggested. So I'll just not make it anything. We'll just go inside of this database too. That is our database instance. So you can see over here, we have that MySQL Community Edition, right? So we have the endpoint of the database to connect with it. Apart from that, it does have the subnets over here. It is showing the VPC that is being there, the security group, the availability zone, right? If we have monitoring, then we can have, different metrics which we can monitor this. We'll be talking about this a little bit later. Okay, if you want, you can also go with the query editor over here. So no database that support query editor. This only is supported with Aurora serverless database, right? So I'll just cancel this from here and we can go to databases back again. And this is our database number 2 that we created. Right. So all the actions you can take it from here. You can set up the read replica if you want. You can set up the EC2 connection. You can stop this temporarily so to avoid unnecessary charges. You can convert this to multi-AZ deployment. If you want, you can also have blue-green deployments. It's one of the technique of deployment that we are going to discuss soon. We can take the snapshot of it for backup purposes, right? So all of these things are possible and you can just connect to the database using this particular endpoint and your username and the password. So once this is being done, I guess yeah, that's all for this particular database thing. Once you're done with this, you can connect to this database using this database endpoint and the admin username and the password using any of your client, right? You can just go with the MySQL workbench or you can also go with MySQL command line. You can use any of the tool and connect with this database and create tables, run the queries, etc. That can be done over here. So that's it for this demonstration for RDS.